So what? We know the p-value. What do we do with it? The rest of this chapter, we're going to decide whether to accept or, excuse me, I said that wrong. We're going to decide whether to reject the null or fail to reject the null by comparing our p-value to our significance level. If you want me to be 95% certain when I reject the null hypothesis, then you compare p to 0.05. If you only care that I'm 90% certain, then you would compare p to 0.1. And here's a this memory tool isn't really useful for me. Let me read it and I'll tell you why. If p is low, the null must go. In order to know what that means, you have to, well, no, must go and be rejected. I got that, no problem. But if p is high, the null will fly. Confuses me because I want to go fly away. And that would be that'd be the same as must go. Whatever helps you remember. If p is less than alpha, then we're going to reject the null hypothesis. If p is greater than alpha, then we're not going to reject. That will fly does not mean will fly. Or will fly away. It means will not be rejected. All right, let's do a few examples on finding p-values and using them to state the initial conclusion, either reject the null hypothesis or fail to reject the null hypothesis. After today, we're going to use the calculator to find p-values, but today we're going to make sure you understand what a p-value is as it represents area. Number 34 says with alternate hypothesis p is not equal to 3/4, the test statistic is z equals 0.35. Now, the fact that the alternate hypothesis has not equals in it means this is what kind of test, a left tail, right tail, or two-tail test. When you have not equals in the alternate hypothesis, that tells you you're conducting a two-tail test, and the z-score is 0.35. So for this p-value, we're looking for the area in both ends of the normal distribution, the area beyond the z-score, z equals positive 0.35, and the area to the left of z equals negative 0.35. How do I find a z-score that has, how do I find an area that is to the right of the z-score 0.35 or to the left of the z-score negative 0.35? What function on the calculator do I use to find the area or probability to the right of the z-score 0.35? Well, I have shaded from 0.35 to 9,999, or forever to the right, and that's what we use for an upper boundary, so I use normal CDF. Normal CDF, I have shaded from 0.35 to 9,999. I want that probability or area, and it is 0.363 if we round to 3 decimal places. That area is 0.363. I'm going to go ahead and round to 2 decimal places, 0.3632, which means this area is also 0.3632. Since the p-value for this test statistic is the area in both ends, I could either add those two areas together, or I can just use the area the calculator found with normal CDF and double it. That p-value is 0.7263. in some of the homework problems, this is what you're going to have to do. Find the p-value and then state the initial conclusion. You'll remember from the previous slide, we have to be given some significance level. We were told to use a significance level of 0.05. And for that significance level, 0.72 is much greater than 0.05. The mnemonic device we used was if P is high, that means higher than the significance level, then the null will fly. That means I don't have to reject the null. I'm going to say fail to reject the null hypothesis. Again, fail to reject does not mean to accept. We just don't have enough evidence to support or reject this conclusion or the claim that was being made. So find the p-value, and if p is greater than alpha, then you fail to reject the null hypothesis. If p is less than alpha, then you reject the null hypothesis. All right, on number 35, the alternate hypothesis is p is greater than 1/4. Is that a left tail, right tail, or two-tail test? The greater than symbol pointing to the right means this is a right tail test. And so the p-value that we're looking for is the area to the right of the test statistic we're given. And the test statistic is 2.3. So I'm going to use normal CDF to find the area from 2.3 to 9999. .3 to 9999. That probability is 0.0107. And the initial conclusion is based on whether that p-value is greater than the significance level or less than the significance level. With the significance level of 0.05, is this less than 0.05 or greater than 0.05? It's less than. And if p is low, the null must go. We must reject the null hypothesis. And we haven't talked too much about the final conclusion yet. We'll do that in just a minute. But that either means that I have enough evidence to support the claim or to reject the claim, depending on what the claim is. All right, one more. Number 36. The alternate hypothesis is P is less than 0.7777. Is that a left tail, right tail, or two-tail test? The inequality pointing to the left means it's a left tail test. And that means that our p-value is the area to the left of our z-score. We're looking for the area to the left of negative 2.95. So I'm going to use normal CDF. I've shaded forever to the left, so I'm going to use negative 9,999 and say normal CDF, negative 9,999 up to 2.95. Sorry, that was supposed to be negative 2.95. And that probability is 0.0016. Compare that to the significance level of 0.05. 0.0016 is less than the significance level. And again, if P is low, the null must go. we have to reject the null hypothesis. All right, we've done all of the parts of a hypothesis test except for the final conclusion. We've done the middle, which was basically establishing the I think I said the wrong thing. We've done the beginning, which was basically establish the null and alternate hypotheses. We've done the middle. We have found p-values. We understand significance levels and how to state the initial conclusion based on whether our p-value is greater than the significance level or less than the significance level. All that's left is for us to learn how to state the final conclusion in terms of the claim, and we'll do that in Part B.